So now we're going to talk about binary arithmetic. That is, how do computers do math with just ones and zeros? And we're going to talk about this because we've seen some math already and we're going to see a lot more, and I want to make sure we all have a basic introduction to it. So we've already seen some examples of binary math here. We saw subtract 2, we saw is 0, and add 1. All of these things were done by the computer in the example we saw, and they need to be able to do math. Now the question is, how do we actually do this sort of math when all we have are on-off? So we don't have a circuit that has a value 2 on a wire. Our wires can only have 1 or 0 on them. Now I'm assuming, as I said, everybody's seen a little bit of this before, so this should be just a quick review. If you haven't seen this sort of binary math before, you're going to want to go and review it on your own as well. So here's an example of binary numbers starting with only positive numbers. So 0 is just 0, and then 1. This is now 2. 1 is 1, 1 0 is 2, 1 1 is 3. So this is 1 plus 2, and then 1 0 0 is 4. So this is the 1's place, the 2's place, and the 4's place. And in general, you can look at this, it's the same way as we have with base 10, except it's the power of 2. So the first digit is the 1's place, the second is the 2's place, the third is the 4th place, and the fourth digit here is the 8th place. If this was base 10, you'd have the 1's, 10's, hundreds, and thousands place. So there are lots of ways to do numbers that are signed, that is positive or negative. Right now we're just going to talk about unsigned numbers or positive only numbers. So now let's talk about addition of binary numbers. So here it's just like you do regular addition. So we're going to add two values together. We're going to add 0 1 and 0 1. This is 1 plus 1, and we're going to get 2 or 1 0. So here's our addition, 0 1 and 0 1. Go ahead, we look at the first two. Now 1 plus 1 in binary is going to be 1 0. So we're going to carry the 1 and we put the 0 down. We take the 1 that we carried, we bring it over to the next column. Now we have 1 plus 0 plus 0, which is going to be 1, and we have no carry out. So we got 1 0 or 2 when we added 1 and 1. So this should be pretty straightforward. It's the same as regular addition. Let's take a look at another example here. So here we're going to add 0 0 1 1. That's 1 plus 2 or 3 plus 0 1 1 0. And this is going to be 2 plus 4 or 6. And we're adding 3 plus 6, and we expect to get 1 0 0 1. This is 8 plus 0 plus 1 or 9. So let's go ahead and do the math. Start out with 1 plus 0, we get 1. We have no carry out of that. So our next one is going to be 1 plus 1. Now when we add 1 and 1 together, we get 1 0. So we put down the 0 and we carry the 1. The 1 gets carried over to the next column. Now we're adding 1 plus 0 plus 1, which is going to give us, again, a 1 as a carry and a 0. And then we carry that into the last column, and now we get 1 plus 0 plus 0, or 1. So this gives us the number we expected. This is 9. This is 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. So a few things to note here. We used 3 inputs in addition. We got A and B, the numbers we're adding, plus the carry in. So here was the way we did that. We had A plus B, and we had the carry in from the number before that. Addition generates 2 outputs, the sum and the carry out. So here's the sum we get from A plus B and the carry out. So an adder has 3 inputs and 2 outputs. Now there's a question, what happens if we have a carry out from the last bit in our number? What does that mean? So imagine we have this scenario. We're adding up 2 numbers and we get a carry out all the way on the edge, but there are no more numbers over here, no more bits. What does that mean happened? So let's take a look at an example here. Here we're going to add 11 plus 6. So 11 is 8 plus 2 plus 1, and 6, which is 4 plus 2. And we expect to get 17. So let's see what we actually get. Here's our 11 and 6. We do the addition. We add the first two together. 0 plus 1 is 1, no carry. 1 plus 1 is going to be 1, 0. So we're going to have a 0 and a carry. Move the carry over. Now we're adding 1 plus 0 plus 1, which is going to give us 0 plus another carry. This carry moves over. Now we've got 1 plus 1 plus 0, which is going to give us 0, and another carry. Okay, but where does that carry go? Well, the problem here is we don't have any more bits left. We had a number that had exactly 4 bits. And so we were limited in how much we could put in there. So math we did here said 11 plus 6 equals 1. And that's not right. If we'd had another bit, we would have gotten 1 0 0 0 1, which would have been 16 plus 1 is 17. But we only had 4 bits. So we had a problem here. We had to carry out of the last bit. And we don't have enough bits like this, we can't represent the number. So there was no way to have the number 17 with only 4 bits. So we knew our math added up to 17, which is more than we could fit. This is called an overflow. So with 4 bits, we can represent 1111, it's just 15, to 000, which is 0. In general, you can represent 0 to 2 to the n minus 1 with n bits. So here's a question. Which of the following numbers cannot be represented with 4 binary numbers? Well, the answer here is 16 and 31. So 0 is just 0 and 4 binary numbers. 8 is 1, 0, 0, 0, 4 binary bits. But 16 is 1, 0, 0, 0, 0. We need 5 bits for that. And 31 is 1, 1, 1, 1, 1. So we also need 5 bits for that.